Welcome to the AI Research Roundup. I'm Alex. Today, we are looking at a paper from the Hugging Face Trending List, published on November 27, 2025, about 4 days ago. It introduces a compact 6 billion parameter image generator that rivals top commercial systems in photorealistic images and bilingual text rendering, while training for about 314,000 H800 GPU hours, roughly $630,000, and running in under a second on modest hardware. The paper is titled Z-Image, an efficient image generation foundation model with single-stream diffusion transformer. And as we will see later, the results show that state-of-the-art image quality does not require massive proprietary models. Also, the author shared a pretty complete GitHub repo. You get the official Z-Image models and variants, a clear quick start script using the diffuser's pipeline, plus detailed reports and PDFs on the architecture, decoupled DMD, and DMDR. There are examples, performance notes, and practical tips for faster, memory-efficient inference. Figure 1 presents a gallery of images that demonstrates how convincing the photorealism of Z-Image Turbo already is. The collage spans portraits, pets, street scenes, landscapes, fireworks, and indoor shopping shots, so it stresses versatility rather than a single narrow style. These samples matter because they show sharp details, natural lighting, and coherent backgrounds that resemble high-quality smartphone or DSLR photos. The figure also hints that the model handles people, objects, and complex compositions within one unified system. Figure 2 highlights that Z-Image Turbo is not just good at making pretty pictures, it is also very strong at writing clear text inside images in both Chinese and English. This figure shows a collage of posters, book covers, and product or event ads where the model renders titles, subtitles, and small labels with accurate spelling and layout. The variety of fonts, colors, and compositions demonstrates that the model can keep text legible while still matching each design style, which is crucial for real creative and commercial uses. So while Figure 2 focused on text quality, Table 1 shows how inexpensive the full training run actually is. This table summarizes GPU hours and dollar costs for low-resolution pre-training, Omni pre-training, and post-training, so it makes the compute footprint very concrete. Low-resolution pre-training uses about 150,000 H800 hours, and Omni pre-training is only slightly lower. Post-training adds under 30,000 hours, bringing the total to about 314,000 hours, which corresponds to roughly $630,000 at $2 per GPU hour. Figure 10 explains how the single-stream diffusion transformer routes all information through one shared transformer backbone, which is key to keeping the model compact yet powerful. The large block at the top shows text, image, and semantic embeddings entering small modality processors, then being concatenated into a single token stream that passes through repeated attention and feed-forward blocks. The two cat rows at the bottom compare plain generation versus editing, where an instruction reshapes an existing photo instead of starting from scratch. On the right, smaller diagrams zoom into a single attention block and a single feed-forward block, highlighting the normalization and gating tricks that stabilize training. So while Figure 10 unpacked the architecture details, Figure 11 shows how the full training journey turns that backbone into usable models. The diagram starts with low-resolution pre-training, then Omni pre-training, which together create a shared base for all tasks. From that base, the upper branch adds supervised fine-tuning, few-step distillation, and reinforcement learning with human feedback to form Z-Image. The lower branch continues pre-training and supervised fine-tuning specifically for editing, which produces Z-Image Edit. Alright, this table shows that the compact Z-Image Turbo model actually ranks among the very best text-to-image systems when real people judge the outputs. The ELO score here is a chess-style rating that goes up when a model wins head-to-head comparisons, so it reflects consistent preference. Z-Image Turbo lands 4th overall, but first among open models, with a win rate around 45% against strong proprietary systems from Google, ByteDance, OpenAI, and others. So to wrap up, Z-Image shows that a carefully designed 6 billion parameter model with single-stream diffusion can match or beat much larger proprietary systems in photorealism and bilingual text. The broader message is that top-tier generative imaging can be genuinely accessible and affordable. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.